So once again, guys, so we are looking for the marginal cost. That means that all we need to do is to find the derivative of the cost function, which we did at the beginning. This is, if you are confused about the steps, this is what you should have done to the function in order to easily find its derivative. You can do the product rule, but why should you bother to do the product rule if you can do it easier? Right? So this is how you should have rearranged the function to get the derivative. So the final expression for the derivative is like this. We don't want negative exponents because eventually we're going to work with this formula. So we want to make it with the positive exponents. And once I have differentiated the cost function, so I found the function of marginal cost. Now all what I have to do is to sub in the value 1225 into the derivative function, which will give you the value 1.07. What is important? As usual, the units, right? So don't forget that derivative.
Sorry for the interruption. This is the last call for all grade 10 students. If you did not take your picture yet, please head down to the secondary office immediately. All grade 10 students.
Okay, so remember always the derivative function is a slope, right? It has units in the numerator and denominator. So in this case, y values are dollars and x values are liters, right? That's why it's dollars over liters. Right, and final question, C. How much production is needed to achieve, just a second, a marginal cost? You have a question about B? Yeah, please.
Where's the R prime of X?
Here it's just an info. They're telling you that marginal cost looks like this, marginal revenue looks like this, and what is it? But they don't ask you the question about revenue because the revenue function is not given to us. Okay, so in question C, how much production is needed to achieve a marginal cost of $0.5 per liter? Suggestions? Yes?
We do the 37.5 root x equal.
So we basically need to equate, this is the value of the derivative function, and we need to find what's the corresponding x value, right?
It's going to be 5,600.
Very good. So in C question, 0.5 is equal to 37 over 0.5 over square root x. You found already the value, right?
Yes.
So it's x what?
It's 5625.
5625. Does anyone need what's the unit on?
Liters.
Liters. Very good. So guys, does anyone need explanation about how to solve this? Yes. So what's the first step in solving this equation?
Which one?
This one.
We have to isolate.
In what way? Yeah. So if we cross multiply, Abdurrahman, how will it look like if we cross multiply? Abdurrahman. Yeah.
0.5 times square root x is equal to 37.5.
Good. Next.
Then you divide by 0.5.
Yeah.
And then you.
So square root x equals what, guys? When you divide by 0.5. 70 what? 5, right? I think 75. Right. And the last step, guys. You square, right? You square both sides.
How is the half of we go to
Okay. So this gives you this x value. All right. Good. That's easy because this kind of questions
Sorry for the interruption.
give you already the
This is
function.
the last call for all grade 11 students. If you did not take your picture yet, please head down to the secondary office immediately. Thank you.
I tried this before. It didn't help. Guys, let's move on. So the next question for today is the maximizing the revenue. So basically, under this big type, I identified 3 subtypes. I want to tell you that, let's say you are practicing on your own and using textbook. I want to tell you that there are more types out there, but I picked up only some of them because I cannot do everything. I cannot cover everything with you. So it means that when I'm assessing, I'm taking only the types which we took, okay? So there are some related to actually directions, some like boat traveling and all this stuff. Unfortunately, I don't have time to take it, but those questions will come in the vectors section, something similar, but with the help of vectors. So if you study on your own, and a lot of people do, only go for the questions which are on the slides, okay? So the second subtype, which I have identified, is maximizing the revenue. So in this kind of question, you have to model the revenue first. And I hope that those students who at least were with me since grade 10, you will remember these questions, because you started modeling these questions in grade 10, right, Omar? You will definitely remember, I'm sure. So let's take this question. It's an example on page 148, question 1, but we will model it together. So I need your help. Let's see how successful you were in grade 10. Page 148, example 1.
Looks very familiar.
Exactly. That's not this one. Sorry, just a second. 48. Boys, I think you should sit separately.
I think the role he gave to me.
Yes. Please sit separately. Just move here, please. It distracts you. By the time I copy this question, you are sitting separately, okay? I copy and paste, you sit separately. Thank you. All right. We'll practice the same skill. You will I'll be asking you questions so that you are able to digest the information and give me the info from there. What is the first question which we have in the algorithm? Guys, don't look there. Listen to me. What's the first question in the algorithm? One person at a time. To model the function is the second question. What's the first question? In the algorithm.
What question says to understand?
This is very hard. You decided to go with the steps from the textbook.
But the question we did before?
Yeah.
Find the cost.
What's the first question of the algorithm?
Find out if it's minimum or maximum.
So what are we optimizing, right?
Yeah,
So what are we optimizing? So look now into the question and tell me, what are we optimizing? Which means we are looking for minimum or maximum. Yes, no?
maximum.
Okay, good, but this is less important. What is it? What we are optimizing? What is
The largest cost of the revenue.
revenue? So we are optimizing the revenue. This is the first one, and in particular, we are looking for the maximum revenue. Okay, good. So we are optimizing the revenue. Now, my second question: what is the second step in the algorithm?
What question is this?
Model the revenue, right? So we need to model the revenue. It's an example. This is page 148 on example 1. Example 1. But I don't want you to look into the text. Example 1. So revenue, and we are looking for the maximum revenue, and we are going to model it now. So now, based on your knowledge of revenue and the information which is provided in this question, so what is the formula of revenue suitable for this question? Because revenue can be expressed using cost, using profit, using quantity, and so on. So based on this question, what formula of revenue is suitable? Noor? Gennady.
The tickets, so say the cost, cost of tickets.
Formula, yeah? So this is good. Or price or cost of the tickets? Price of the tickets, and then what
What's
else?
the number of passengers? So
Plus? So when you need to again, selling the chocolate, one chocolate is £5, you sold 100. How to find the revenue? Yes?
Cost times quantity.
Exactly. Or in this case, it's price. I'm selling a chocolate for £5. I sold 100. Multiply, this is your revenue. So that means that the revenue in this question.
The revenue. I'm asking a lot. We missed a lot of asking.
You need to structure your thinking. I'm doing all the efforts to structure your thinking.
What thing?
You are somewhere, exactly, what thing? No, I mean, you are somewhere else. Like, I'm in the second step, I'm modeling the revenue. Revenue is quantity times price. Did you hear that?
Yes.
Good. So, quantity times price.
What did I figure around? Isn't that the derivative?
No, it's not. Okay, so revenue is quantity times price. Good. This is the formula we're going to use. Now we need to model the function, right? We need to think about the variable and we need to model it. But at least we know that the function will look like a product, right? Do you see that it will look like a product?
Yes, it does.
It does look like a product. Good. So it means that all we need to do is to express quantity and to express price. So as the price changes, the quantity will change. So tell me, the price of what? What are they selling in the question? Chocolate? Okay. They're train tickets. They're selling train tickets. Good. Okay. And the quantity of what? Of whom? Of passengers. So we have tickets, train tickets versus passengers. Now, so we're going to think of how to model the price of the tickets, and we need to model the quantity of passengers.
Are they putting the tickets in the chocolate?
Look, Abdurrahman, we can have fun, but you will not benefit from it as much as if we focus on the question, right? So tell me, yes.
So the price is going to be 7 per person.
What kind of price is it? It's the price which they're charging right now. So we can say that it's an initial or original initial right now, right? In the current moment, they have a price of $7. So initial price is $7. What about initial or current quantity? Yeah, 2,000. Good. Now, Omar, when they increase the price, what normally happens? How does this affect the quantity? It decreases. Look, please just listen to the question. You have to practice this skill. So if you increase the price, the quantity decreases. What, Omar, happens when you decrease the price?
Decrease the price?
Yeah.
Put more passengers.
The quantity.
The quantity increases, right? It's natural, like in the ideal world. This is how it happens, right? So now it means that we're going to do something to the price, and it will naturally affect the quantity. So now my next question is, what is the increment of change? Like, how are they going to change the price? Abdurrahman, no, it's not imagination. It's reading the question. How are they going to change the price? Are you ready to answer? No, Abdurrahman, I got offended?
No.
Abdurrahman, please, I'm saying that it's not a question to think about. It's a question to analyze the data from the question. So how are they going to change the price?
40 fewer.
No, it's 40 is not the price. Omar, 0.10. So 0.10 is the increment of change, whether increasing it or decreasing. What's important is that they fixed this increment, right? So that means if I'm going to increase the price, shall I add or subtract the increment? I add, right? So it's either adding 0.10 or subtracting.
7x plus minus.
Just a second. Now, let's do the same with the quantity. Guys, what will happen if they increase the price by 0.1? Abdurrahman. So if they increase, is it minus? Is minus, right? So if they increase, then it's going to be minus 40. If they decrease, it's going to be plus 40. Okay. So now, based on this, we have to model any change in the price, which will affect the quantity, okay? So I will, while you're thinking how to do it, I will write down. So we are modeling the function a revenue, R of X. There will be a variable there, but we have not agreed yet what is going to be there. So you will have two expressions multiplied, right? So one of the expressions is going to be the quantity expression. Let's start with the price because price affects the quantity. So price expression, and this is the quantity. Okay. So any ideas what to start with? Yes, Habiba.
So 7x, right?
No. So we will have the initial one. So we'll have the initial one here. Yes, Abdurrahman.
But it would be easier to graph them and see where they
No, we are not going to graph them. Graph what? We don't have any, graph what? You don't have functions to graph. You can graph when you have a function.
Isn't artificial like every 2000 x and x is equal to 40 and it keeps increasing by 40.
Okay.
And
So
7.
last chance and then before I say anything. So the revenue depends on what? The revenue depends on
The price of the
the change in the price of the quantity. So don't you remember this question from grade 10 and 11? So how to represent the change in the price? Plus what?
Plus 0.1.
If I add 0.1, how many times has the change occurred?
Once.
Once.
0.10.
Yes. So 0.
Oh, okay.
Plus
Would it be plus minus or just?
0.10x. In fact, in this question, they don't impose anything on us. So we can increase the price, then what will happen to the quantity? It will decrease, or vice versa. We can model this or that way. So based on this, what's the quantity?
2000%.
No, it's
Noor?
2000 minus
Mhm.
40 to the power of x.
Oh, wait.
Power of x?
40x.
I think you said the answer every time. It's just.
40x.
It's not a question.
Because you are Noor and Noor, and I don't know, I'm not thinking about the second name. Okay, any questions?
Yeah, I don't know. So if one of them is plus, the other one has to be minus.
Why? Tell me why.
Because one increase and one decrease.
Whenever price increases, quantity decrease, and vice versa. If you decide to model it as minus, then here it will be plus, right, Ola? Okay.
Right.
Good. So this is the difficult part, right? We have modeled it now.
Now it's easy.
Now it's easy, exactly. Let's follow the algorithm. Once I have modeled the function, what do I do next? Omar.
We can graph. Find the derivative.
It's a new step in the algorithm.
Get the derivative.
Derivative. Okay, I will not do it right now. It's already done in the so r prime of x, and then when I know r prime of x, what do I do next, Habiba? This is expand is an operation. I'm talking about big steps. If I have the derivative, Abdurrahman,
It's going to be the derivative of the first times the second plus the first times the derivative.
guys, I'm not asking how to differentiate. It's the past, it's the history. You know how to differentiate. Yes.
It's not in the number of new passengers.
We find it, we equate it to 0.
Exactly. You just said that. So we equate it to 0. This is the third step. I'll not do it now. Because it's done in the textbook. We'll check it to save the time. Fourth step is very important. What is the fourth step? The interval, okay? So, guys, now, I don't know, online people, I know I get carried away because they're here, but you are not participating. Ask questions, okay, as we go. So, the question for online people, and you guys think about it as well. Read the question and tell me what information is provided in the question for us to make up the interval, to design the interval. So no, you think first, but mainly it's a question for online people. But you think as well if they don't respond. Guys online, I see who else. But you think what is limited? Yes, it is given, but what is limited, right? So Abdallah.
Miss, I'm thinking.
Mina.
I'm
Mina,
thinking.
Abdallah, guys, do you see the information in the question, which is given some clue to us about the interval? Tell me, what's the information? Just a second.
It's 2,600 passengers.
Only the
Like
interval.
from 0 like to 2,600.
So
And 1,600 also.
yeah, so let's formulate it.
So x is greater than or equal 1,600 and less than or equal to 2,000.
Okay, it's good that you see that there is a maximum and minimum, but of course it's not x. Okay, it's important because we didn't mention. Just a second, guys.
2,000.
What is x? Good that you mentioned it. Practice raising your hand without saying anything.
The number of passengers?
What is x? Let's go back to our modeling process. What's x? It's not the number of passengers.
The cost?
The maximum.
Guys, please, it's not guessing, right? You need to look at the model. What is x? Yes, Omar.
It's the number of working people is increasing. For
That's the change.
On the right track, but you try to formulate it better. Yes? What did you say? The amount of changes. It's not assessed, okay? Don't worry, okay? So, amount of changes. So I changed once, this is the price, this is the quantity. I changed twice and so on. So that's why, do you understand why it's not, these values are not limiting x. They're limiting something else. Because x is amount of changes. And those values are people, right? So you can't. Yes, please, what do you want to say?
I know the limits.
Yeah.
X is bigger than or equal 50, and smaller than or equal 70.
How did you get the values?
Because we can't have negative amount of people, and we can't make the people get one.
And x is not people.
I don't say.
So we can have a negative value. Okay, look. I will go through just to save time, and then we'll, if you have more questions, you'll ask. So now, we said that this is limiting amount of people. So tell me, in the function, which expression is this limiting? Yeah.
The quantity, right?
They both are stealing.
Yes. So do we put the equation of the quantity equals the 1,600 or 2,600?
What equals? It's inequality.
Yes, but it can be equal. It's still the same.
It will be easy if yes.
Would you just say like one on each number and then put it instead of quantity?
No. Keep saying equal. I'm saying why does it have to be equal?
Make it less than or greater than
Exactly.
and then we just solve for x, and whenever we get for x,
Absolutely. Yes. So tell me, finally, this is called double inequality. Remember advanced functions? So the double inequality, please, Noor. What shall I how to write it?
So write 2,000 minus 4x.
In the middle.
Okay, so on the right side, the right hand is less than 2,600. On the left side, 1,600.
Okay, good. So this is the way we are going to identify the interval. Who knows how to solve double inequality?
Miss, don't we like take it two?
By doing the middle one.
The first step?
Don't we like take one side and then we solve it?
No,
just do the middle
it's
one.
much easier. Noor?
The middle one.
What you do to the left side, you do to the right side. So
To all three sides.
you subtract by negative 2,000.
Yeah. So the first step you subtract 2,000 because you are isolating x in the middle. So subtracting 2,000. So what's on the left?
Negative 40.
Right. In the middle.
Negative 40x.
Okay. And on the right?
600.
600.
Okay, great. Next step, just a second. Omar Sharif. Next step in the solution of solving double inequality.
Miss, you divide by negative 40.
So you change the
Omar
sign.
Sharif.
And you switch the signs.
And reverse the signs. Okay, so x, now you reverse the signs because you divide by negative. So what's on the left, Omar?
It's going to be 10.
And on the right?
15.
Negative 15. Now, you remember, this cannot be final because in inequality, there is a fixed order. It has to be from left to right. So you can write it as double inequality from negative 15 until 10, or if you prefer interval notation, you can write it as from negative 15 until 10. This way you can see the endpoints. Right, great. Next step.
Miss Natalia,
Yes.
I don't understand this part.
I don't understand is not something which I can help. You have to ask a question.
He said, I don't understand this
the
part.
line- Abdallah, the line, solution line, which you have the question about. Ask me.
The interval.
So the interval started here.
Yes, I don't understand this part.
So the interval here is me.
I know the maximum and the minimum is 2,600 and 1,600.
You don't understand why is it less than 2,600 and greater than?
Well, I know these are the maximum and minimum, but I don't know what.
But you don't know what? You don't know why this expression is here in the middle?
Yes.
Okay, so do you know that in the revenue function, you have, guys, before I'm repeating this step, so I need from you the next step, okay? So you need to be ready to tell me what's the next step. So Abdallah, in the revenue, we have only one expression which shows us the amount of people. And this expression is the quantity of people, right, of passengers. Do you agree with me?
Yes.
And also in the question itself, also it says that this is the maximum passengers, amount of passengers, this is the minimum. So by question, the limit goes to the quantity of passengers, not to the price. In some questions, you will have to be ready to identify, maybe the price will be limited. Because, for example, in the market, there might be upper bound for the price, right? So, but in this question, the way it's formulated, the limit goes to the quantity. That's why I take this quantity expression from the revenue function, this one, and I say that this expression can be should be less than 2,600, but it has to be greater than 1,600, because this expression represents how many passengers are going to be there.
Okay, I understand.
All right. So and then you solve double inequality. This is advanced functions. Right. Step number 5. Who is ready to tell me what to do at step number 5?
Yes, I know.
Okay. I want Asir to tell me. Asir,
we're gonna sub in R of 10, R of negative 15.
Can you raise your voice, please?
We're gonna sub in R of 10 and R of negative 15.
10, R of 10, R of negative 15, and what else? And what else?
Zero.
And R of, I'll write it like this, 0 of what? Of the derivative. Because for me, what matters is that you know the structure of this process, right? And then which value, which output are we going to pick up, Omar? You're not sure. That's why you need to read the question.
What the railway charge?
That's it? It stopped there? Or there is another part? So if it's the biggest revenue, then which value should you pick up?
Not the 10, the value that...
The output, I said output. So you need to choose, are you thinking or no? You're just looking. Tell me. Maximum or minimum? Maximum. Choose maximum.
Maximum profit.
Okay, not profit. There is no profit here at all, guys.
Yes, isn't you getting profit out of the quantity?
There is no profit. We don't need profit. Abdurrahman, please focus. There is revenue. Where is the profit?
It's going to be 10.
No, let's check if your assumption is correct. So going back to the question, the detailed solution is here. So this is the function that we modeled, right? And then this is the interval, negative 15 until 10, right? And finally, those are the outputs. So which output is the greatest? Which you also think that output is 10, the 10 is, you also think that output is 10 is output? No. So listen to the question. My question was, what's the greatest output?
14,400.
Yes, output is 14,400. Input is negative 10, which is not 10, right? You see, assumption is not correct. Now, my last question for this one, and we're done. What does negative 10 represent here?
The zero.
It is, but for the function, in terms of not operations, what does negative 10 represent for this revenue function.
Is that changing the price or number of changes? Changing the price?
Yes, so the conclusion is to maximize the revenue. Do we need, Noor, it's again to you guys, don't shout. Do we need to increase the price or decrease the price to maximize the revenue? Based on the fact that this is -10. Decrease the price. How many times, Abdurrahman, do we need to decrease the price to maximize the revenue? If it's -10.
Negative 10?
10 times. What should be the price if you decrease it 10 times?
For 2,000. The price.
It's the price. So I want the pool right
Sorry,
here.
it's going to be 6.6.
So the price is
6.6.
6. 10 times 10 cents gives you $1, right? So it's 6. Okay, done. Oh my God, this is 10:50. Oh my God, this is too long. Okay, 20 minutes. There's no break, unfortunately. There's no break. The break. Okay, guys, I'm going to stop recording because the last question we're going to do it in groups. I will explain now what to do, and.